Hi everyone. In today's lesson we're going to talk about graphing piecewise functions. Yesterday we talked about evaluating them graphically and algebraically, and today we're going to actually graph them ourselves. So in this first example here, you can tell that our piecewise function is made up of a quadratic because of the x squared and a line. But we're going to have the quadratic when x is greater than or equal to 2, and we're going to have the line when x is less than 2. So the first thing that I would do is pause the video, go grab your calculator, and then hit resume. Okay, so what we're going to do is we're going to put into the y equals, into the calculator, negative x squared minus 3x plus 10. So take a minute and do that. Okay, now you're going to hit second table. And we're going to just focus on values that are greater than or equal to 2. So let's see what we come up with in the calculator. So pause the video and resume once you've done so. Okay, so you should be getting 2, 0, 3, negative 8, and 4, negative 18. I'm going to stop there because I know that negative 18 isn't going to fit on the graph. So I'm going to graph this quadratic here in black. So 2, 0 is this point right here. And 3, negative 8, 3, 1, 2, 3, is right here. So that's enough. I won't even fit the 4, negative 18. And we're going to connect it. So that's part of my quadratic. Now notice that I have a closed circle here because of the line under it. Now I want to graph the line here. So clear out whatever you have in your y equals and put in y equals negative x plus 2 into your y equals. And look at the table. And once you do that, we want values that are less than 2. See over here, x is less than 2. So we're still going to put the 2 here so that we could put it with an open circle. So we should have 2, 0, and go less now. 1, 1, 0, 2, negative 1, 3, and negative 2, 4. That's enough because that's all I could fit right now. And let's graph. So we're going to graph the point 2, 0, but x cannot equal 2. X has to be less than 2. So we're going to put here a closed circle for this point. So this point is open circle. So let's do this. 2, 0. That point right there. I'm just going over it to show that it's open. And now 1, 1, 0, 2, negative 1, 3, negative 2, 4. You can keep going if you notice a pattern, or you could just extend the line. So here we've got ourselves a piecewise function made up of a line when x is less than 2 and a part of a parabola when x is greater than 2. So the first question you want to ask yourself is, does this graph represent a function? Well, a function is something that passes the vertical line test. You draw any vertical line through the graph, and how many times does it hit? Once. How about this line? Hits the graph once. How about this line? Hits the graph once. This line hits the graph once. And so on and so on. So see, this line hit it once, this line hit it once, hit it once, and hit it once. So we would say yes, this is a function. All right. What's the domain? The domain is how wide the graph goes in either direction. Well, it goes wide forever because there's always going to be a value to hit, and it always is going to go right forever. So the domain is actually negative infinity to infinity. And the range now. How high does it go and how low does it go? Well, it goes low forever and high forever. So negative infinity to infinity as well. Alright, so if that was confusing, let's try another one. So in example 2, we have a piecewise function made up of an absolute value, a line, and a cubic function this time. So we only want the absolute value function from x is equal to negative 3 to 3. So in the y equals, in the calculator, put in the absolute value of x minus 2. in case you weren't sure where those absolute value bars are, you want to hit Math, scroll over to Number, and hit 1 for ABS. So take a minute, put that into the calculator, and write down a chart of x and y values for x values that are between -3 and 3. So -3, -2, -1, 0, 1, 2, 3. So pause the video until you've done so. Okay, this is what you should have gotten. You should have gotten -3, 1, -2, 0, -1, -1, 0, -2, 1, -1, 0, and 1. So take a minute graphing all these points, but make sure that you closed circle or you used closed circles around the -3 and the 3 because of the lines. Okay, this is what you should have gotten. So -3, 1, -2, 0, -1, -1, 0, -2, 1, -1, 2, 0, and 3, 1. That's your absolute value function. So we can go ahead and connect that. Okay, so now the second one, f of x equals 3. That's the same thing as saying y equals 3. Just if you remember, here, if we have a y equals, it's just this line right up here. This is the line y equals 3. Basically, y is 3 every single time. So if I have an x value from -3 to 5, we would do x, y, positive 3, 3, 4, and 5. It's going to be 3 every single time, the y value. And if you don't believe me, you can go ahead and put that in the calculator. So basically what we're going to do is we're going to graph these points now. And again, they're both getting closed circles because they're a line underneath them. So 3, 3 would be here, 4, 3, and 5, 3. So we've got this piece right here. That's my line. And the last but not least part would be my cubic function. So y equals x minus 5 to the third power when all values of x are greater than 5. But we need to include the 5 here so we can put an open circle. So take a minute, pause the video, put x minus 5 cubed into the calculator, and look at the table. And hit resume once you've done so. Okay, so you should have gotten when x is 5, y is 0. And we're going to go greater than that. So when x is 6, y is 1. When x is 7, y is 8. And when x is 8, y is 27. Now that's too high because that won't fit, but let's go ahead and graph this. But remember, when we graph 5, 0, it's all x values greater than 5, so this point will have to have an open circle. Alright, so let's graph 5, 0. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. Open circle. 6, 1. 7, 8. And that's all that'll fit. So here's part of my cubic function. And now this is my piecewise function, made up of an absolute value, a line, and part of a cubic. Alright, so the question of the day is this a function? Well, any line that I draw here will hit this function once, but how about right here? How many times does it hit? It's hitting here at the line, and it's hitting here at the absolute value. So since it hit twice in that spot, the whole thing fails. It's not a function. Now what's the domain? The domain is how wide it goes. It only goes as wide as here. So -1, -2, -3. And it's going to have a bracket around it because it's an open circle. A closed circle at -3. And it goes all the way to infinity. So -3 to infinity, close. And now the range is how low and how high it goes. So it's going to go as low as -1, -2, and as high as infinity. So again, since it's a closed circle here, it's going to be a bracket. So bracket 2 to infinity. Awesome. Why don't we go to the next page, and I'd like you to try it on your own, and then hit resume to see your final answer. Okay, this should be your answer. So the first thing I did was I graphed the y equals negative x squared, which was this piece here. It got a closed circle because there was a line under it. Then I graphed the line from 0 to 1. When I graphed the 0, I had a line under it, so it had a closed circle. And when I graphed the 1, I had an open circle, so that's why I closed open. Okay, then I did the line y equals negative 2, and it's all values x that are greater than 1. It doesn't stop, so it goes on forever, and it's going to be a closed circle. So when x is 1, it's closed, and it goes on forever. So first question, does this graph represent a function? The answer is no, because here's where it fails. Look right here. You see how if I were to draw a vertical line through here, it's going to hit here and here. It doesn't quite fail here because this is an open circle up here, so it goes right through it, but here it hits. So here it would only hit once, and here it hits twice. So that's why it fails. If you have questions about this, we'll definitely go over it tomorrow. I know it's hard and visually to see. So what's the domain? It goes on forever this way and forever that way. So all real numbers. The range is it goes from negative infinity to 0. Then there's a gap right here. And then it goes from 3 to 5, including 3, not including 5. So let this sink in a little bit. Think about some questions that you want to ask, and tomorrow we'll go over the entire thing. Okay, have a good night.